Welcome to AI Horizons, One Day in AI Research. In this episode, we'll explore 7 fascinating AI research papers published on July 16, 2025. Today, we're exploring the frontiers of AI research. We'll unveil key research published in a single day, July 16, 2025, providing an accessible overview of cutting-edge AI advancements. We'll highlight key themes, findings, and future directions, making complex concepts understandable for all. Join us as we journey into the future of intelligent machines. Let's begin with an overview of artificial intelligence. AI is the science of making machines smart, creating machines capable of human-like intelligent tasks. This encompasses language understanding, image recognition, and decision-making, revolutionizing industries and solving global challenges. It also augments human capabilities, automates tedious tasks, and generates new insights from vast amounts of data. One key research theme is multi-agent systems and collaboration. This explores how multiple AI agents collaborate to solve complex problems. She et al. Introduce AIM, a framework for autonomous multi-agent collaboration, enabling AI agents to communicate, negotiate, and strategize, tackling problems too complex for a single agent. An example of this would be swarm robots cleaning a disaster zone. Another central theme is reinforcement learning. Here, AI agents learn by receiving rewards for good actions and penalties for unfavorable actions. This is useful for tasks without explicitly defined rules, and agents are trained in diverse environments, from games to robots. However, it can be computationally expensive and require careful reward function design. One such example is the use of rewards and punishments in training unmanned aerial vehicles to navigate. Strategic reasoning and game playing represents another major area of research. Games offer well-defined rules and clear objectives for AI development. Chen et al. Enhanced strategic reasoning in large language models for Chinese chess, also known as xiangqi. Mastering games develops algorithms applicable to real-world problems, improving decision-making and strategic thinking, using game environments as testing grounds. Let's look at some key findings. Chen et al.'s xiangqi R1 outperforms general large language models in Chinese chess. Lin et al.'s BuildEvo achieves state-of-the-art building energy forecasting. Kim et al.'s new partially observable Markov decision process, or POMDP, solver outperforms benchmarks in dynamic environments. Han et al. Demonstrate topology-enhanced multi-agent reinforcement learning, or TPE-MARL, improves traffic efficiency. Finally, Rajbindari et al. Uncover bee-inspired unmanned aerial vehicle navigation secrets. Several methodologies are driving these advancements. Reinforcement learning allows agents to learn through trial and error. Large language models are pre-trained on vast text and code datasets. Multi-agent reinforcement learning extends reinforcement learning to multiple interacting agents. Evolutionary algorithms mimic natural selection to optimize solutions. Finally, tree search algorithms explore decision sequences for optimal actions. Let's examine a specific research paper, Chen et al. 2025, xiangqi R1, Enhancing Spatial Strategic Reasoning in Large Language Models. The objective was to improve large language models' spatial reasoning in Chinese chess, also known as xiangqi. The method included fine-tuning, strategic annotations, and reinforcement learning. xiangqi R1 outperformed general large language models in move legality and analysis, demonstrating the potential of task-specific training for large language models and showing that large language models can be specifically trained for games. Next, we'll consider Lin et al. 2025 and their paper BuildEvo, Large Language Model-Driven Evolution for Energy Forecasting Heuristics. The objective was to generate effective and interpretable heuristics for building energy consumption. The method used was in large language model guided evolutionary process based on physical insights. The findings showed state-of-the-art performance and enhanced generalization, providing transparent prediction logic for critical infrastructure. The novelty here is the combination of machine learning with physics, making it easier to interpret. Let's delve into Chen et al. 2025, Partially Observable Reference Policy Programming, Solving Partially Observable Markov Decision Processes sans Numerical Optimization. The objective was to develop a solver for partially observable Markov decision processes, or POMDPs. The method was partially observable reference policy programming. The findings show that the solver outperforms online benchmarks in dynamic environments, providing a new approach to solving partially observable Markov decision processes. This is useful in real-time complex scenarios, such as a helicopter emergency. Now let's look at future directions. We anticipate continued progress in multi-agent systems, reinforcement learning, and explainable AI. The field will likely see the synergizing of the strengths of different AI approaches, as well as efforts to reduce the computational resource demands of large language models. Ensuring fairness and mitigating biases in AI systems will also be a priority, as will developing AI agents with human-like understanding and interaction. This synthesis was created using AI tools including GPT using Google's Gemini 2.0 Flash model, TTS synthesis using OpenAI, and image generation using Google. A human expert then reviewed the synthesis. Potential oversights may still exist. All references are provided. Subscribe to AI Frontiers on YouTube for more AI content. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive-preprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive-preprintserver.org.